Hello everyone. In this video we are going to deconstruct the array reduce method. We're going to create reduce from scratch and try to follow the process through which this method evolved, and we're going to try to sketch out the need behind the reduce method. So we're going to recreate reduce in order to better understand this kind of notorious method with all these kind of like complicated syntax and these different use cases. Most beginners find reduce a little bit intimidating. So we're going to create this function from scratch in order to understand how it works and also become more familiar, more comfortable with using it. Before I start coding, I want to try and see the definition of the word reduce so that we can better understand what this reduce is all about. So I'm going to go to Google and I'm going to search for the definition of reduce just to get a better idea. So the dictionary says that reduce, the verb reduce, is about making smaller or less in amount, degree, or size. So what reduce is, in the general sense of the term, about making, taking something and reducing it in terms of the size or the scale or the degree or the amount. So this is the idea behind reduce. This is, of course, the definition of the actual verb reduce, but the method reduce and the intention of the reduce method is very, very close to this definition. So let's start by coding. So in a very, very basic example, reduce is all about reducing one value into another value. Okay, like for example, reducing a number into a string. This is very simple, but we're going to follow the path, and we're going to eventually see the more complicated, more complex example. So reduce is about getting some value and reducing it, returning some other value. Right? So in this case, for example, we're going to get a number and we're going to reduce it to a string. I know this doesn't make much sense right now, but please bear with me. So I'm going to reduce number 42 into a string. So basically it's about a transformation that is taking place. A value is being transformed into another value. Now this is a very simple conversion, so that's why we're going to move on into a more into a better example, which is closer to how the array method reduce works, which is reducing a list, an array of values, not just a single value. So an array of numbers, for example, into another value. That can be, for example, a number which is the sum of the numbers. So we're going to reduce a list of numbers. So let's say nums, and we're going to get the total. We're going to get the sum of these numbers, which is 60, of course. So the function reduce will accept an array, and then it will return the sum. So I'm going to start with an initial value. I'm going to set a variable sum. I'm going to initialize it with 0. It makes sense to start with a sum which has the value of 0, and then return the sum. And in here, of course, in between, I'm going to accumulate the values from the input array and add them to the sum variable so that I can get the number 60 out of this reduce operation. So result will be reducing the nums array into their sum, which I'm expecting to be 60, right? Of course, I'm not getting 60 because I haven't yet implemented the code here, the logic that will accumulate the values. So in here, what I want to do is iterate over the values of the list, which is passed as an argument here when I call the reduce function. So I'm going to iterate through these values, and then I'm going to add its value to the sum variable so that I can get the actual sum from this array. So I'm going to use the for of loop, and I'm going to iterate. Now I'm going to just console log to see what's happening. So the reduce function gets the array argument. It's filled with this value. I'm passing nums. So array here is the list which contains 10, 20, and 30. I'm iterating over its value 3 times, of course. The array length is 3. So, and I'm console logging, of course, the first, the second, and the third array element. So a simple iteration over this array. Now, since I want to add its number into the sum, I'm going to say sum equals sum plus the value. So every time I'm adding the current value, 10, 20, 30, to the value of sum, so that I end up with 60, as you can see here. So pretty simple operation, reducing an array of numbers into their total, into their sum. Okay, let's move on to another example so we can start seeing the pattern behind the reduce. Now I'm going to have another example, which is going to be an array of numbers, and I'm going to get the average from this array of numbers. So once again, I'm going to use the same array, and I want to reduce this array into the average. I'm going to start with undefined. For this one, I'm going to start with some value like 0. I'm just going to start with undefined and then gradually build something based on the array elements so that I can get the average. In this case, I want to get the result, which is going to be an average. So I'm going to pass the nums list again and get the average, which of course is undefined. So once again, I have to iterate here over the values of the input array and accumulate the values and operate on these values. Why? Because I want to produce the average, not the sum, so I need to do some extra steps into this function. Once again, a for of loop, console log val, just to see the values. Okay, we get the values. So let's add these values to a variable called sum. So we can then operate on the sum, like divide by the length of the array so that we can get the average. So I'm going to just say sum equals sum plus value. And in here I'm going to get, of course, 60. Okay, and then if I divide the sum of the 3 numbers by their size, by the length of the array, so either by 3 or by array length, which is of course 3, I'm going to get the sum. Now I'm going to make this a little bit terse. I'm going to use this operator to add the values to the sum, and then of course I'm going to say average equals the sum divided by the array length, so I can get the average. A slightly more complicated series of operations here. So once again, I'm getting the sum, I'm iterating over these array elements, I'm doing some calculations, doing some extra calculations here, just dividing, and then I'm going to get the average. I'm doing this because I want you to see that a pattern starts to emerge. In these two reduce operations, we started with some initial value, with some accumulator. We iterated over the input array. We did some kind of calculations, some kind of operations on these array elements, and then we returned the variable, the accumulator. In this case, it was the sum variable, which contained the sum. In this case, it's an average, and it's also being returned. And now I'm going to go to yet another example, a little bit different and one step more complicated. So I'm going to get an array of arrays, and I'm going to produce a flat array. So what I mean by this is I'm going to get an array of arrays like this, and I want to flatten, as we say, this array and produce just a one-dimensional array with just the values. So I'm going to reduce this two-dimensional array into a one-dimensional array. So another reduce function that accepts an array. This time I'm going to say output, or let's say flat array. I'm going to initialize this value with an empty array because I want to get a one-dimensional array, so I'm going to initialize with an empty array. I really want an array to come out of this operation. I'm going to iterate over the values once again. I'm going to console log them. I'm going to do something. I'm going to perform some kind of operations here so that I can return the flat array, which of course is going to be the expected value. So let's say result equals reduce array console log result. Of course, I'm going to get an empty array, as you can see here, but I'm going to put some more operations here so that I can get the expected result. Once again, an array as an input, an initial accumulator value, iterating over the values. We're going to do something with these values, and then we're going to return the accumulator. So we're going to combine the accumulator with the values of the array, and we're going to modify the accumulator so that it contains the result that we want, which is this array containing all the values. Now, as you can see, its value in this initial array is an array. So if I want to pick the values out of these arrays, I have to also iterate through these inner arrays. So let's say this is inner array. Let's rename this to inner array so that it makes more sense. So I'm going to loop over these inner arrays, const, and I'm going to console log so that I can see the values. So as you can see here, I'm going to comment this, I'm seeing all the values that I want. Iterating over the first level of arrays, getting the value 1 and 2 from the first array, getting the values 3 and 4 from the second array, getting the value 5 from the last array. And at this point, I have all the values I need, and all I have to do now is push them to the accumulator. So I'm going to say flat array push inner val in order to get the result. A third example of a reduce operation, just to see the pattern that starts to emerge from these three different reduce operations. So we have the reduce function, which always accepts an array. I want to reduce an array into something. We have some initial value. We will call it accumulator. We're going to use a more generic term in here because in these three cases we have an average, we have a sum, and we have a flat array. But as a general pattern, this is some kind of an accumulator value, some kind of value that accumulates values based on the array values. We're going to iterate do some operations on these values, and then return the accumulator. This is the basic reduce pattern. So I'm going to create like a pseudocode. So the reduce pattern so far at least is, first of all, accept an array as an input, to initialize an accumulator, let's accumulator with some value or none. We kept it undefined in one of these operations. We iterate over array values, then we do something. We modify the accumulator based on its value from the array, right? And then, of course, we return the accumulator. So this is the general pattern of the reduce. This is the basic logic behind reduce. Drop some array into the reduce, iterate over these values, do some operation, do some calculation, and then out of these operations we insert some value into the accumulator. The accumulator starts accumulating some sort of structure, some sort of final value, and then at the end we return the accumulator with the final value, the one we want to see at the end of the reduce operation. So this is the basic logic behind the reduce function. Now, of course, in these three examples, we had three different functions where each one of these was doing just one thing. The first one was reducing an array of numbers into a sum, the second one into the average of the numbers, and the third one was just flattening an array. The reduce function, of course, is a general purpose array method. It's able to accept any array as an input and transform this array into any kind of value. So we have an array, we have some kind of transformation, any kind of transformation, and then we have some value. That can be any value. It's not just restricted or limited to getting the average or the sum or flattening an array. It can do any kind of transformation on any array. That's why it's the most powerful array method. So in order to create the reduce method and be able to recreate it so that it can accept and do any kind of transformation, so that it's not limited to one kind of transformation, I have to modify the function that I have been using so far so that it can accept some custom transformations. So in order to do that, we're going to keep the basic pattern, which is the accumulator with some initial value. Okay, this pattern will be the same. I'm going to have an accumulator that will be returned. That's the basic idea behind the reduce. I'm going to iterate over the array elements. So I'm going to say for const val of array, and now in here, so this is a more generic form of the reduce function, I'm going to do something with val and accumulator. Okay, so this is the basic, the more generic or general purpose format or form of this function. Instead of in here applying an average logic or a sum or a flattening or flatten, let's say, operation, I'm going to leave this open to any kind of transformation. So how can I make this function, this reduce function, being a general purpose, being a reduce function that can do any kind of transformation? And let's see that, let's just add an example here. I'm going to once again try to recreate the sum. So I'm going to recreate, but this time I'm not going to hard code the logic behind reducing a list of numbers into a sum inside the reduce. I want this to be a general purpose function. I'm going to pass this logic as a parameter. So I'm going to say this logic, which is summing up numbers, is going to be passed as a second argument, so that I can reuse reduce with many transformations, so that I can reuse reduce with some kind of averaging numbers, or I can say const r of arrays equals reduce some kind of multi-dimensional array, let's say, of course, and then pass some kind of code in here, some kind of instructions into the reduce function so that it can flatten this input array. So going from a single purpose function from the previous examples, which we had 3 reduce functions that each one did just one thing, we're going to create a general purpose reduce function which accepts an input, in all cases an array input, and then based on a second parameter with some custom transformation logic, we're going to be reducing the initial array into a sum, an average, or in here, let's say a flat array, not an array of arrays. This is the input. So let's start with the first example, which is passing an input, an array of numbers, and then summing up numbers. Of course, the summing up numbers is not defined, and I'm going to define it. Now, the logic that will go into this reduce function, as you can I guess, contains a lot of operations. So the only value that I can use that can provide these instructions is a function. So it makes sense to create a function and pass a function as a second argument, so that I can execute many operations, run many commands in here. So reduce the nums into some kind of a result, which is the sum. What happens here? I start with an initial value. What is the initial value that I want in this case? So in this case, I want this accumulator to start with 0 and then add sequentially all numbers and get the sum. So this I want to be 0. But by hard coding the initial value of the accumulator, I'm also limiting and restricting the purpose of this reduce function into accepting 0 as an initial value. But I don't want to do that. I don't want to have the accumulator always be 0. I want it to be a custom value. So that's why I'm going to pass this initial value of the accumulator as an argument also. So how am I going to pass it? First of all, I have reduce called with the initial array. I have a second argument here, so I need a second parameter. So I'm going to name this transform because it's going to be a transform function, so that I can pass this custom logic, and then the initial value can be the the third parameter. So this initial value. So I can pass 0 here as a third parameter. So I can say, okay, I want to start with accumulator being 0. So now in this case, I can initialize the reduce operation with the accumulator set to 0. In another operation, for example, in the average, I can just omit the initial value and have this set to undefined. For example, so I get sum is not defined. For example, if I started to average, I could just omit the third parameter, and then this accumulator would be would have an initial value of undefined because I'm not passing a third parameter. And if I were to, let's say, use the third reduce example, then I could use an empty array as an initial value. So in this way, I can customize the reduce function so that it can accept any kind of initial value for the accumulator. So a third parameter. And this is how the reduce function actually works. So let's work our way to the next steps. So I'm passing the array, I'm passing the transform function, and I'm passing an initial value. So far, so good. But we need to iterate in here and do something with these values so that the accumulator starts accumulating some kind of value that we will eventually return. So in this case, since the transformation is going to be some custom transformation, and this transformation will be a series of instructions passed as a function, I'm going to call this function, so transform function, with the value. So now when the reduce function gets executed, it will accept a function as a second argument, and it's going to call this function with every value of the array. So if, of course, this transform function reflects this function, I'm going to say val, and as you can see, the summing up numbers is being called 3 times. So it's passed as an argument. We're iterating over the array values. We're calling transform function, which is of course summing up numbers with every array element value, and we're getting the value. Okay, I'm accepting the value. I can do something with the value, but just having on its execution of this function, just having access to a single value doesn't make too much sense, because I want to accumulate the values. I want to do something to the accumulator, so I need also access to the accumulator. And in order for this function to have access to the accumulator, I'm going to pass it as the first argument here. So I'm going to say the first argument, I'm going to pass the accumulator. In this way, this function will get executed for every single value. So it will have access every time on each of the values of the array, but it will also have access to this accumulator value, and then it can do something with this accumulator. For example, in the case of summing up numbers, it's going to add something to the accumulator. It's going to add the value, to add its value to the accumulator. So I'm going to say, hey, add 10 to the accumulator, add 20, add 30, and of course return the accumulator. So every time I am going to add something to the accumulator and I'm going to return it. Now this being returned right here, so I'm going to accept the value into the accumulator. Now we're iterating over the list of array elements. We're calling this function, we're passing the accumulator so that the function has access to this accumulator. We're getting the previous value of the accumulator, we're adding the value, and we're returning the new result, which is the accumulator that contains the new value. Let's see how this works. So we have previous accumulator, which is ACC. We have console log value. As you can see, we get the accumulator and the value each time, and then of course we get and we're returning the next accumulator value. This is how the summing process works in this case. So on the first iteration we get these 3 values. Now the output here is a little bit misleading, so I'm going to make this into a one string, console log let's see this in one single console log. So let's see 3 iterations. So on the first iteration, we have the accumulator passed into the summing up numbers. Of course, the initial value will be passed, which is 0. The value on the first iteration is 10, and after we add the value to the accumulator, now I'm going to add the accumulator to the value to the accumulator. So after we add the value to the accumulator, we will get 10. On the next iteration, the accumulator has the value 10 from the previous iteration. The value is 20, we are adding 20 to 10, and we get 30, and we're returning it. So on the next iteration, the accumulator is 30, the value is 30, 30 plus 30 is 60, and we're returning this. And the whole loop stops, and we get the accumulator, which is 60. So we have, let me remove this, and then we're going to do this. We just we were able to do exactly the same thing as we did in one of the first examples right here, but this time we didn't integrate the logic of summing up the numbers inside the reduce. We passed this whole logic as a function and as a parameter to the reduce function. So then this reduce function remains a general purpose reduce or transformation function. It is not limited to just summing up numbers. It can also work with other kinds of transformation. So now let's try and move on to the next transformation. Let's reuse the same function so that it can get the average of the numbers. So I will comment this, and now I'm going to copy this, and I'm going to go to the next step. And now I'm going to get the average of the numbers. So instead of passing a function that will sum up the numbers, I'm going to average numbers. Okay, so another function that will do something different this time. And then I'm going to say average here and average here. Now in this case, of course, I don't want to see 60. I want to see the average of these numbers. So I want to see 10 plus 20 plus 30 equals 60 divided by the number, by the length of the array, which is 3, and I want to see 20. So I want to see here 20, right? Of course, something is not right here because I still have the summing logic inside here. So what do I now need to do to this function so that it gives me back the average of the numbers and not the sum? So in this case, the function just gives me the sum of the numbers, right? And the sum of the numbers, the total, let's say, of the numbers can be found at the last iteration. So when I add 30 to the previous accumulator, which is 30, and I get 60, I get the value 60, and then everything stops. The average numbers function stops executing, and I get 60. At that point, when I get the sum from these 3 numbers, is when I want to. So when I get the final sum, I want to divide the sum by the array length, which is 3, okay? So that I get the average. So the average is the sum of the 3 numbers divided by the number 3, which is the number of elements. So in this function, I need to add some more logic. So I need to add some things, some more commands, so that I can get the average. Okay, so the things that I need is, first of all, to detect when I am at the point where I get the final sum, when I get 60. So let me console log here let me console log accumulator. So this function gets executed 3 times, and then at the third and last execution we have 60. Now at this point, the last time that this average number function gets executed, I want to detect this last step. I want to see that, okay, now I'm at the last element and I have just added the last array element into the accumulator, and at this point I want to divide by the array length. So how can I detect that I am right now, right here, at the last step of the array? Now, one way we can do this is, of course, to check at which index number we are currently in. So when we are in the last array element, when we're in the last step, the index number will be 2. The index number, the last index number, is always equal in an array as to the array length minus 1, which is of course 2. So 2 equals the array length minus 1. If this array consisted of 4 elements, the last index would be 3. Let's say we have a list 1, 2, 3, 4. The index, of course, would be 1, 2, 3. 3 is equal, the last element, the last index, of course, is equal to the array length, which is 4 minus 1, which is of course 3. So one way to detect in JavaScript and in almost all programming languages whether an array element is the last element of the array is to compare the index number, which means the position of that value in the array, with the length of the array minus 1. So in this case, at this point, I need to do some operation. I need to compare the index with the array length minus 1, right? And then when this if index equals array length minus 1, which means we are at the last element, then I'm going to divide accumulator by the array length, right? This is the pseudocode. This is the logic that I need to implement. Now, at this point, I don't have access to the index and I don't have access to the array inside this function. So I'm missing two very, very important values. Now, how can I gain access to these values? Remember that this function, this transformation, this custom function gets called in here from within the reduce function, and the arguments that we pass to this function are defined in here when we call the function. So if I want to access the index, the current index, and the array, I need to pass these values also as arguments. So I define two parameters here, two placeholders, and then I have to pass these values when I call the function, so that I can pass the index from here to here and the array into also this fourth parameter. So I need to add two to call this transform fn function with two more parameters. So I need the index, which of course right now it's going to complain. Now the array is of course the array, right? I just get the input array and I pass it as the fourth parameter. So the array is already here, but the index is not here. Why it's not here? Because I'm using the for of loop and I don't have access to the index this way. So I'm going to transform this for of loop into a simple for loop where I can get the index. So I'm going to say let I equal 0. I'm going to say I'm going to use the a common pattern, which is to start from a counter, or which is a variable named I, or I will name it index, I will start from 0, and then I will check whether that index has reached its end, or whether the index is less or equal to the array length, so that I can stop the iteration. Okay, once I've reached the end of the array, I want to stop the iteration, and at every iteration, of course, I add 1 to the index so that I get from 0 to 1 to 2, and then iterate through the array. So I'm transforming this for of loop into a more general purpose index loop. Now the value right now, as you can see, I have just removed the value, so this is no longer here. So in order to get the value, I have to use the array index format here. Okay, I no longer have a single variable that contains the value. I just have the index, the position of the element in the array. I have the array, so if I combine these two, I will get the value of the element. So everything works as expected. And now I'm also passing the index and the array, which are needed in this function. So let's go here and console log the index and the array. So you can see now, every time this custom function runs, and I not only have access to the accumulator, the value, but I also have the, let me have the value. So I have the accumulator, I have the value, I have the index, so the place of the position of the value in the array, 0, 1, 2, and I also have the initial array. So now I have everything I need to do this check. If I want to check whether I'm in the last array element, I can say, of course, if index equals our length minus 1, console log last element reached. Okay, so I can see the console log once, and I see this when the index and the value is, of course, 2. This is the last index, and the value at index 2 is 30. So now I know that I have reached the last element, and it's time to divide, as you can see here, to divide the accumulator by the array length, so that I can return back the average and not the sum. So in this case, I'm going to say accumulator equals accumulator divided by array length. And then, of course, I'm going to see the average of this operation. So by adding 2 more parameters to the custom function, to the transformation function, the index and the array, we're able to do so much more in the transformation functions that we pass to reduce. So as you can see, the transformation function needs the accumulator, it needs the value, it needs the index and the array. Now we have the reduce function, and the next test that we need to do is see whether this can be used with for example, another kind of transformation, the transformation that we did earlier, which is to flatten an array. So in order to put this new reduce function into the test, I'm going to test the next another transformation. Before moving on, I want also to just add one more change to this reduce function, so that I can run this operation without providing an initial value. The original array reduce method gives us the ability to omit the initial value. If we want to not provide, for example, an initial value, we can omit the third parameter and just supply the array and the transformation function. Now in this case, since we don't provide an argument here, the initial value will be undefined, right? So the accumulator will start with undefined, And as you can see, the transformation fails here. We get not a number and not 20 because something wrong happens in here. Instead of starting accumulating from 0, we're starting to accumulate from undefined, and then bad things happen. So in this case, whenever we omit the third parameter, the initial value, reduce has some logic, logic that says, okay, if the initial value is omitted, I'm going to use as the initial value, I'm going to pick the first value of the array. So if we omit this parameter, reduce by default will pick a value. It must initialize the accumulator with a value. So the most logical thing to do is to pick the first value of the array that we pass to it as an input. So what the reduce function does, it says, okay, if the initial value is empty, which means undefined, I am going to pick the first value from the array as the initial value. Okay, I don't want to leave things with values such as undefined, because as you can see, bad things can happen. So what we can do here is we're going to check whether the initial value is undefined, and if it is undefined, so if we have omitted the initial value, we will pick the first array element and set this as the initial value. So in here, what we're going to do is we're going to do a check, and we're going to say, is the type of the initial value equals to undefined? If it is, then we're going to pick the first array element and provide it as the initial value. Otherwise, we're going to use the initial value. So if we have 0, we're going to use 0. This check will be false. So the initial value, the type of initial value won't be undefined. It will be 0. It will be a number. So we're going to use that initial value 0, but if it's not, if it's omitted, sorry, we're going to use the first array element. Okay, so we started accumulating from the first array value, but as you can see, the result that we get is a little bit strange. Why does this happen? In order to see what goes wrong in here, I'm going to console log a few things here. Let's console log some of these things. So as you can see, we are iterating 3 times, and we're starting with 10. We're getting the accumulator is 10, the value is 10, and then we're adding 10 to the accumulator, which is not exactly right. Then we get the accumulator, which is 20, the next value is 20, then we add 20 to 20, we get 40, and then we have 30, we add 30 to 40, we get 70, and then we try to get the average, and we get this kind of special value, this strange value. So this is 70 divided by 3, and we get this kind of like weird looking floating number. So something is not quite right in this case. And why is the case? Because as you can see, we're not starting with 0. We haven't set an initial value, so we're picking the first value, and we start accumulating, we start adding the first value once again to itself. So we omitted the first part, the initial value, we started from 10, and then we're adding 10 once again to the accumulator, which is not right. Okay, so this happens because we have skipped the initial value, we have started the accumulator with the first array element 10, and we are iterating over the first array element, which is not right. So if we omit the initial value and we set the accumulator to the first value, we need to skip this step, right? So we need to move on to and start the iteration from the second element onwards, because we don't want to add things to operate on the initial accumulator value. We want to skip the first step and then start from the second and third element and so forth. So in this case, if the initial value is undefined, we need to skip the second step. So the way that we do it is inside this for loop, we need to say, okay, if initial value, or let's say if type of initial value is undefined, okay, so if we use the first array element as the accumulator value, and if this is the first step, if this is the first iteration, which means that index is 0, we want to skip this iteration. And in the for loop, we can skip an iteration with continue. So once again, when we omit the initial value, we just pick the first array element, and then we continue the iteration from the second element onwards, so that we don't have these strange and unexpected results. So in this case, we have to do a conditional here, and we're going to say if type of initial value equals undefined, and if index equals 0, so if this is the first step, then continue. So if I now leave the console log here, by adding this conditional here, we're making sure that our reduce function works even when we omit the initial value. So if we omit the initial value, the first array element is picked and is used as the first initial accumulator value, and then we start iterating from the second element onwards, so that we can see the expected result, which is 20, the average of these three numbers. So by adding this last step into our reduce function, we make sure that the reduce function is working also when we omit the initial value, the third argument here. Okay, the average number works. Now let's take this reduce function and test to see whether it works with another transformation. So I will comment this, and I will go and test to see if our function works with the array of arrays into a flat array. Let's see if what we did so far makes sense and it produces the result that we want. So I'm going to go to this function. I'm going to pick this array, and I'm going to say, okay, flatten array. Let's make this an arrow function. Why not? And I'm going to say flat array equals reduce initial value is the array, flatten is the function, and we are going to console log the flat array, which of course we expect to be 1, 2, 3, 4, 5. Okay, we get undefined because our flatten array. So this transformation function needs to be passed as the second argument to the reduce, so that we get the result that we want. We want to flatten an input array, so we need to pass another function. Once again, even though I won't be using all the parameters of this transformation function that is passed to reduce, I'm going to start by including all the parameters in here. So I'm going to start with the first one, which is always the accumulator, the value of each array element, the index, and the original array. Let's see whether we get these values correctly. Okay, let's see. I think we get, so we get the accumulator. As you can see, I have omitted the accumulator, so I'm seeing the first array element. In this case, I'm going to pass an empty array. So on the first iteration, I get the accumulator, which is an empty array. Then I'm getting the value. This is the first element, then the index, and then the whole array. On the second iteration, I'm getting undefined. Why am I getting undefined? Because I'm not returning the accumulator. So I always have to return the accumulator in order to see it in the next iteration. And now I get to see this same pattern on every iteration. This function will display the accumulator, the value, the index of the value in the array, and the whole array. So I have everything I need so that I can move on to transforming these values. Now, what I want to need to do right here is to iterate from its value, which is of course an array. Cannot element of value. So I'm going to iterate over these elements. Let me see. I have a console log. Okay, so I'm going to return. I see 1, 2, 3, 4. Yes, okay, but I have to use element. Okay, so let's put the value here so that we make this a little bit more clear. So I'm iterating over the first value, which is 1, 2. I'm iterating over this array, so I get 1 and 2. Then on the next execution of flatten, I get 3 and 4. I iterate over 3 and 4, and I get the values 3 and 4. Then on the next execution, I see 5. I iterate, I see 5, and just console logging things. So now, instead of just console logging these values, right, 1, 2, 3, 4, I'm just going to push them to the accumulator. And then I'm going to see the final result, which is a one-dimensional flattened array containing the numbers 1, 2, 3, 4, and 5. So there you have it. We reused the reduce function. We didn't change anything. We just transformed the transformation function. We just passed a custom function which accepts an array of arrays, and it flattens this array. So now a reduce function is a general purpose function that accepts an array, transformation function, an optional initial value, and gives back the result that we want. So far so good, but we haven't finished yet. We have one more step, and that is to get a little bit closer to the actual reduce function that is built into the language. And the nice thing about the reduce function is that it is built inside the language, inside JavaScript, and we can use it directly in an array. So we can say 1, 2, 3 reduce, passing of course some parameters, or we can of course say const list equals a comma b, and then list reduce, and then we pass a transformation function here. So the transform function in the the built-in reduce method doesn't we don't need to pass in the array as the first argument. We just execute the reduce function directly on an array. So we don't have to call it as a function with two parameters. We just pick an array, we say dot reduce, it's an array method, and then we just pass the transform function and the initial value. So how does this happen? How can every array in JavaScript be able to call the reduce method? That happens through the array prototype. So Array.prototype.reduce equals some function. So the prototype is the object which links every array that we create in JavaScript with the reduce method. By saying Array.prototype.reduce equal function, we're making sure that every array we create will inherit this method, and then we can call this method directly through the array. If we want to use to do exactly the same thing with our custom reduce function, we will have to rename our function so that we don't override the built-in reduce function. So I'm going to rename this to my reduce, and I'm going to link this to the array prototype. So I'm going to get a copy of this function, and then I'm going to say this is my reduce function, and I'm going to connect it to all the arrays by saying prototype my reduce equals my reduce. So by doing this, let's see that I don't have an execution. Okay, yes. So now I don't have to say my reduce array and pass a function, an array here. I can just pass these two functions, and I can say 1, 2, 3, 4, my reduce transform function, let's say average, and the initial value. Of course, the average is not defined. I have to define the average, the transformation function, and once again, accumulator value index array. And I'm going to say accumulator equals the value and then return the accumulator. Now I'm going to see here index function average index value accumulator missing semicolon. Have something here. Let's see. Let me see. Accumulator. The value, the array index. Okay, so this doesn't work because we removed the first parameter from the myReduce function, which of course we are accessing inside our function. So we removed the array because when we call the myReduce through the prototype, the function by default gives us access to the array that called the method. So in here, the array that will call the myReduce can be accessed through this function through the this keyword. So if I find all the array instances and I replace them with this, then this will be the array. Now, the only thing I have to figure out is why we have a typo here. So my reduce, I get 10, and this is not the average. Of course, this is the sum. So I get the sum. So 3 plus 2, 5, 4 plus 1, 5, 10. Let's add 10 to it and check the function. That's 100, 120. So now the last step, if we want to go one step closer to the actual built-in array method reduce, is to, of course, rename our function to something else so that we don't replace the built-in function, and then connect this to every array instance by saying Array.prototype.reduce and connecting this with my reduce function. Now I have to note at this point that we should never do this. Okay, we should never add custom methods or properties to built-in objects through the prototype in JavaScript. We just let JavaScript deal with its prototypes and methods. We don't want to do this because if at some point in the future a new method is introduced into the language called myReduce, probably not, but we don't want to mess and have conflicts. So this is why we never add methods or properties into the prototype of the building objects, such as objects, arrays, functions, and stuff like that. The only reason why I'm doing this is because I want to show you how this works by connecting all the array instances with a method, and then we are able to call this directly through an array. So now let me double check with the same myReduce function, but with one of the values. Let's take this array and let's make sure that it works. So I have this constant array and I want to flatten it, so I am going to get the flatten method. I'm going to uncomment it and let's see if this works. Now I'm going to directly call myReduce on the array, and as you can see, I get the result that I want, that I'm expecting. So this prototype method also works on the flatten example. And before we wrap up, let's also check the average. So I'm going to get the average here, and then let's place it here. Let's uncomment this, and then let's say once again 10, 20, 30 myReduce. Now I'm going to say average numbers, and I'm not going to pass in an initial value, and let's see. So it works even by passing only a transformation function. We've reached almost the end of this video. We've recreated the reduce function from scratch. I hope you realized why we now need all these parameters that we need to pass most of the times into the transformation function. You've seen how we can use an optional initial value. Before we wrap up, let's just like test this function with an example that reduces value or transform a value not into something simpler, but into something a little bit more complex than the initial value. So let's start with an array, and then I'm going to directly pass a function here. Let me okay, my reduce function, so accumulator value. Let's use just the first two parameters. Return accumulator. Okay, let's console log the output, and I'm going to see the output somewhere here. Okay, and let's have an initial value. Now what's this? As an initial value, I'm going to set an object. Let's make this, so let's comment some of these operations here so we get a cleaner output. Now in this example, I'm going to do something a little bit more advanced. I'm going to start with an array. I'm going to set the initial value of the accumulator to an object, and then I'm going to return back an object, which is like a structure which is a little bit more complicated than an array. So what I'm going to do is I'm going to create an object that contains a property which signifies the index of the array element. So index and value. So I'm getting the index here for its value, okay, 0, 1, 2, the value, and I'm going to add a property to this object, and I'm going to name this index plus index equals value, and then I'm going to return this. So in this case, as you can see, the output value is something more complex than an array. So we're not actually reducing, we're not kind of like reducing in terms of size or scale or complexity. We're going the other way around. That's why I think that reduce is probably not the best choice of word for this kind of function, because it's actually a transform function. It's actually transforming values, because in this case we're not reducing, we're doing almost the opposite. We're creating a more advanced structure, and of course we can even make this more complex structure. We can output an object which has these three properties. These property names are created dynamically based on the index of its array element, and then they contain another object with the value 10, which can be, let's say, multiplied by 2. So as you can see, a reduce can not only actually reduce, but it can also go the other way around. It can produce something much more complicated and produce a structure that is way bigger and more complex than the initial value. And with this last example, we conclude with the deconstruction of the reduce function. We started from very simple examples and we recreated the whole function from scratch. I hope this gives you some insights on how the reduce function works, and I hope that by now you are going to remember the parameter order, the significance of its parameter that we pass to the reduce. So in here, if I replace my reduce to reduce, you will see that I'm going to get the same result, right? We recreated the reduce, so my reduce is doing exactly the same thing. So if I go here, I'm going to get 120. If I do reduce, I'm going to still see 120. And let's last check the flatten. And as you can see, also the flatten example is working with the built-in JavaScript reduce. So we recreated and we came quite close to the original built-in reduce function. If you want to see the actual code of the reduce function, make sure to check the description on the video. You can find it here on the MDN page at the bottom. There's a link that points to the actual implementation. So if I go here, and of course you can find the link, and you go here, and this will point to the array reduce. Let's go here, internals, array reduce, which is right here. And you will see that it's a little bit more complicated from what we just created. This is the reduce function. And this is a little bit more complicated because this actual create method returns two types of reduce methods, the reduce and the reduce write. If you want to find out more about the reduce write, just head on to MDN and check to see how this method is different from reduce write. Thank you for watching. I would love to hear your comments, both positive and critical, and I hope to hear from you, and I would love to hear your suggestions on whether you like this video and you want to see more deconstruction videos. Thank you for watching.